Okay, here's a trig example of finding relative extrema. So we have y equals secant squared of x on the interval 0 to 2 pi, including 0, not including 2 pi. So those are the same positions. So that just means if you get a value that's at 0, you don't include the 2 pi, which should be the same thing. But let's start. The first thing you do is find the derivative. I'm going to do the derivative of this one because it's a little bit more, I guess, complicated. This is secant quantity squared. So you have to follow the chain rule, which is draw the outside, leave the inside alone. So 2, leave secant alone, secant x to the first. Now times the derivative of the inside, which was secant. The derivative of secant is secant tangent. So this is, we have to find the critical numbers of this. So where this equals 0 or undefined. I suggest to change everything into sines and cosines. It's going to be a lot easier. So 2 times 1 over cosine times another 1 over cosine times a sine over cosine. Which gives us 2 sine x over cosine cubed x. So now we have to find the critical numbers, but only on this interval. So the critical numbers are where the top equals 0. That's where sine of x equals 0. Or maybe where the bottom equals 0, if they're not asymptotes. Or where cosine cubed equals 0, which is the same thing as where cosine, because anything, only 0 cubed is 0, so cosine would have to be 0 for cosine cubed to be 0. So sine is 0, and remember, we're going from 0 to 2 pi. Sine is 0 when y is 0, so here and here. So that's x equals 0, x equals pi. Now, also 2 pi, but we're not including 2 pi. So that's sine. Cosine is 0, then here. I'm going to do those with x's so we can differentiate. That's x equals pi over 2, and x equals 3 pi over 2. So those are all the critical numbers that, well, those aren't the critical numbers, those are where the derivative is 0 and undefined. Now, secant squared, look at the original function. Secant squared is 1 over cosine. So the rules for these to find vertical asymptotes, if the bottom is 0 and the top isn't, and the top is never 0, those are vertical asymptotes. So anywhere where the cosine is 0, those are vertical asymptotes. So therefore, that's not a critical number. That's a vertical asymptote. Same thing with 3 pi over 2. That's a vertical asymptote. 0 and pi are critical numbers, though. Right? So it's easy to tell where this has vertical asymptotes. It's where cosine is 0. And we found that cosine is 0 here and here. So now I'm going to make my chart. Now, for trig, I'm starting at 0, so I can't really use anything over here. I'm ending at 2 pi. And my critical numbers are 0, so that's a critical number. Pi over 2, that's an asymptote. So pi, that's a critical number. 3 pi over 2, that's an asymptote. And 2 pi is also a critical number. So in this area, we have to figure out what to use. Since we have the unit circle, let's use something we know. Let's use the derivative at pi over 4. That's an easy one. That's right here. So look at our derivative. The sine of pi over 4 is positive because you're in quadrant 1. The cosine of pi over 4 is positive because you're in quadrant 1. So it's a positive divided by a positive, which is positive. Next, from pi over 2 to pi, I'm going to use 3 pi over 4. Just makes sense. Now we're in quadrant 2. So cosine x is negative, sine y is positive. So positive for sine, when you plug this in, negative for cosine. If it's cubed, that's okay, because if you cube a negative, it's still negative. So we have a positive over a negative, which is negative. Here, we're going to use between pi and 3 pi over 2. Again, the unit circle is helping us a lot here. We're going to use 5 pi over 4. Now we're in quadrant 3, where sine and cosine are both negative at 5 pi over 4. So we have a negative over a negative, which is positive. And finally, between 3 pi over 2 and 2 pi, I'm going to use this, which is 7 pi over 4. Now we're in quadrant 4, where cosine is positive, sine is negative. So we have a negative over a positive, which is negative. So we're supposed to find the relative extrema. I'm going to give you some more additional information because I don't think I've done this enough. This function's increasing on the intervals 0 to pi over 2 because the derivative is positive, and then pi to 3 pi over 2. It's decreasing on the intervals pi over 2 to pi, and then 3 pi over 2 to 2 pi. Now the relative extrema, or we got a break here, because you're not going to call 0 a relative extrema because that's on an endpoint. There's nothing to compare it to. These asymptotes we can't call relative extrema. The only relative extrema, the only critical number within the whole interval is pi. And pi is a relative extrema because the derivative goes from negative to positive. That means we have a minimum at pi. Now we have to plug pi into the original function, which is secant squared. 1 over cosine squared. That's what we want to use. When you plug in pi, cosine is negative 1. So this is 1 over negative 1 squared, which is 1. We're going to look quickly at the graph. I have it graphed right here. So when you graph secant squared, just graph it as 1 over cosine quantity squared. I'm going to change my windows. So set our window. I know I'm only going from 0 to 2 pi. So that way that will get rid of all the other stuff. I'm going to hit graph. So that didn't really help me that much. I'm going to zoom trig. No, see, I know my window's all messed up. I didn't hit the pi somehow. All right, this should be better. Yeah, it is a lot better. So here's a relative minimum right here. So second count minimum. Left bound. Right bound. Enter for a guess. And it says 3.14 pi, comma 1. So perfect. So hopefully that you enjoyed that. I sure did.